Hello, my name is METİN arkadaşlar. This is 321st part of explanation of my theory. According to my theory and my formulas, Bragg's law and X-ray diffraction cannot determine the size of crystal atoms and their bondings. Can the length of unit cell of a metal be measured using the Bragg's law and X-ray powder diffraction method? Yes. 1. Inner side. Smallest electrons. Okay. Smallest electrons. Yes, these two. This is one electron, this is the second electron, connected each other, and they may connect their protons, smallest wavelength electron, in a multi-electron copper atom with 29 electrons. But there is no identical electrons according to my theory. This is 29th electron. This red one, 28th electron. Green one, 27th electron. Different sizes. Okay. Here I pictured only smallest 0.10721 nanometer wavelength electron interfered each other in the context of their protons, because each electron per proton. There is no two electrons make joint motion with one electron. One electron, one proton. One electron, one proton. Okay. And all protons are connected to each other also. Yes, here. When we shine X-ray with 0.154 nanometer wavelength to a copper crystal, we shine, okay, consecutive waves. It will make proton-bound electrons with wavelength greater than or equal to 0.154 nanometer wavelength. If their wavelength greater than 0.154 nanometer, they will be ionized. They will be free, and according to me, free electron, it is in motion or at rest, produces and propagate consecutive, successive waves, effective waves. That waves affects proton-bound electrons. They make them enlarge, expand, and when they vanish, proton-bound electron motion form shrinks again. While shrinking, produce a single wave pulse. as I told you before. So important. Bragg's law, like billiard balls or other fictions. Wrong. Left side is mine. Now, when we shine X-ray with 0.154 nanometer wavelength to a copper crystal, it will make proton electrons with wavelengths greater than or equal to 0.154 nanometer wavelength ionized free. All of them, except smaller than 0.150. There are two different wavelength size electrons in a copper atom, 29th and 28th electrons smaller than 0.154 nanometer. Okay, I have computed, because according to me, each electron has ionization energy, ground state energy, and we can compute their wavelength. For instance, greatest ionization energy for an electron 11,567.6 electron volts, corresponding 0.10721. This is radius of electron. Each one is electron, middle of joint motion with a proton. Okay, connecting. Yes, there is only smallest 29th electron here, and of course there are second smaller wavelength, smaller than 0.154 nanometer is 28, 0.1121 nanometer, but third smallest electron is 0.459 nanometer. Because of this, greater than 0.154, this electron will ionize, will be free. While it will be free, when it ionized, it starts immediately, momentarily, produce and propagate successive waves, consecutive waves. And these consecutive waves of ionized electron affect smallest proton-bound electron, which made metallic bonding for copper atom, and when coincide one of these, they make it expand, not ionize. This is ionized electron, it's successive waves. I'm so sorry. And when it affects, enlarge this. Okay. And when its effect momentarily, temporarily vanish, this shrinks again. While shrinking, this is single wave pulse at the rate of squared wave number multiplied by initial wavelength of proton bound electron. Okay. But by the way, free electrons consecutive waves is going on, go on, and consecutive waves represented by continuous spectrum, and spikes, emission lines, represented by proton-bound electron motion forms single wave pulses. Without continuous spectrum of consecutive waves, here 0.459 nanometer wavelength size, okay, electron free electron, consecutive waves, continuous spectrum here starts from 0.459 through the smallest electrons wavelength, but here this is a spike like this, smallest electron motion form. Under the influence of this ionized electrons consecutive waves, it produces this single wave pulse, for instance, with 0.154 nanometer wavelength emission line. Without consecutive waves, continuous spectrum, this spike emission line cannot occur. This is two types of light that I put for and I shown you before. Okay, now, and when the consecutive waves vanish, expanded proton-bound electrons shrink again their initial 0.10721 nanometer and 0.1121 nanometer wavelength sizes. Okay. While shrinking, each of these proton-bound electron motion forms will pour out a single wave pulse. You can call these pulses as key alpha and key beta. Okay, like this. Yes. Characteristic emission lines on a continuous spectrum of copper. Since emission lines will not appear, according to me, without intersecting continuous spectra, these lines will occur on the continuous spectrum of consecutive waves of ionized free electron motion forms as spikes. Yes, here. Then, objects are nothing but tissues that made of interferences of proton-bound smallest electron motion forms. Smallest electron motion forms make interference. When they make interference, they bring they bring together individual, for instance, copper atoms. Each one have 29 protons and different wavelength sized electron motion forms. Okay, smallest, this is interference, but red and green, not interference. Living together. Yes. Atoms are connected with each other through these interferences of smallest proton-bound electron motion forms. 3. In X-ray diffraction method application to determine the unit cell edge length of a crystal, X-ray of a certain wavelength causes the formation of two different types of light in a metal, as I told you. Now, consecutive successive waves from just ionized greater proton-bound electron motion form of metal and single wave pulses from expanding and shrinking smaller proton-bound electron motion forms under the influence of X-ray as a successive consecutive waves. Consecutive waves are the sources of continuous spectrum and single wave pulses are the sources of characteristic lines on these continuous spectra. So, here, don't forget, contrary accepted physics theories, there are no identical electrons in a multi-electron atom. Left side mine, right side Bragg's. Incident ray and scattered ray, or elastical scattering. This is wrong. This cannot measure the size of electron, smallest electron, because these theories didn't discern that there are electron motion forms connected with each protons like this, and they are different, and they have sizes. They are not point-like, dimensionless objects or particles. They have 3 dimensions, etc. Bragg's law is wrong, and this measurement is wrong. Unfortunately, accepted physics, macrocosmos measurements and microcosmos measurements are completely wrong. Macrocosmos measurement, as I told you before, are wrong. Age of universe, size of universe, etc. Distances between galaxies. Because accepted physics theories don't know there are 2 different light types. Okay. One type of light, consecutive waves, successive waves, free electron motion from successive waves, light, variable, and instantly give us the information from most distant